Hello, my friends. I hope you're doing well today. So we have just finished talking about the different types of chemical reactions you will encounter in this unit. We talked about combination, decomposition, single and double displacement reactions, and we said that double displacement reactions also involved precipitation, acid-base, and gas evolution reactions. And we just in the last video finished talking about redox reactions or oxidation reduction reactions. So in these next 2 or 3 videos, we're going to sort of backtrack a little bit and talk about solutions. And we're going to talk about those because obviously chemistry has all the solutions. But in your chemistry career and in chemistry lab, you will be dealing with lots of different kinds of solutions. And when dealing with solutions, it's obviously important to know what species are present. If you remember when we talked about double displacement reactions, we needed to know what ions were present to potentially form a precipitate. But it's also important for chemists to know not only what species are present in a solution, but the concentration or how much there is of a particular species dissolved in a liquid. And by far the most common way that chemists express concentration is in terms of this parameter called molarity. Molarity uses chemists' favorite unit, the mole. Specifically, molarity is a measure of the moles of a particular solute, or what is dissolved in that solution, moles of that solute per liter of solution, And so molarity is often expressed in terms of this capital M. The units associated with that capital M are moles per liter. So that's 2 ways that you can express molarity. I really think it's when starting to do molarity problems, I think it's really important to explicitly write down the units of molarity, particularly moles per liter, so you can see your units cancel and feel comfortable that you have set the problem up correctly. So let's do some example molarity calculations, determining how much solute, in terms of moles, is present per liter of solution. So remembering that definition of molarity, which is down here, let's go ahead and do these 2 problems. In this first problem, I ask for the molarity of a solution that contains 0.56 moles of barium chloride in 100 mils of solution. And remembering that molarity is moles of solute per liter solution, I can say that the molarity is 0.56 moles of barium chloride per 0.1 liters, because remember the volume has to be in liters, and there's 1,000 milliliters in a liter, so that decimal place comes over 3 to the left. Setting that up with my moles per liter, because that is the definition of molarity, and then doing the division, I get 5.6 molarity. Or another way to say that is 5.6 moles of barium chloride per liter solution. Let's do another example. In that first example that I specifically gave you moles and volume, although it was in milliliters. What if I wanted to know how many grams of sodium sulfate, Na2SO4, are required to make 0.350 liters of a particular concentration of sodium sulfate solution, specifically 0.500 molarity. So in this problem, I've asked for grams, and I have given you a volume and a concentration. Remembering that molarity is moles per liter, and remembering our algebra skills, we can take this molarity equation and solve it for moles. And once we get moles, we can get grams very easily using molar mass of that species. So for this reaction, for this problem, we're going to go ahead and solve for moles from the molarity equation. So by cross multiplying, so molarity times volume in liters is moles. Once you set that up, so I have my molarity here, 0.500 mole per liter. So I've written that molarity so I can clearly see my mole and my liter units multiplied by the volume in liters. Let me get my little pen here, and then you can see your units cancel. I'm left with moles of sodium sulfate, which is not the final answer, but I am on the path to getting the final answer, which is grams of sodium sulfate. I take that moles of sodium sulfate. I'm going to multiply it by the molar mass of sodium sulfate. So 2 sodiums plus 1 sulfur plus 4 oxygens from the periodic table. And doing that multiplication and division should give you a final answer of 24.9 grams of sodium sulfate. So you should feel comfortable. You should first know the definition of molarity. That molarity is moles of solute per liter solution. Be able to use that definition along with your dimensional analysis skills and your skills of finding molar mass to solve particular word problems. In the next video, we will start with this next slide, which is about ion concentrations in a solution.